Today, I'll talk about product development and those things that we can do to improve our probability of success. Given technical complexities, distribution of teams, and the myriad of distractions, we will need a well-planned and careful particular product to meet our goals, and from the product perspective and monetarily. However, well-planned does not mean well-planned from the start. We have techniques at our disposal to meet feature and quality objectives. In the course of this presentation, we will review the techniques as well as the process mechanisms that can help meet those product targets. We will adopt some aspects of agile project management, product development, supporting processes, specifically configuration management, and numerous techniques to effectively deliver our product to fruition. Ensuring product quality is not solely through the testing and verification activities, though many people may think so. Testing is but a fraction of the techniques that are at our disposal to improve our development quality. Planning of the product incarnations, that is a phased and increment delivery of the feature content, makes it possible for an organization to employ tests, inspections, and evaluations as tools for a competitive advantage. To really improve the product quality, a more comprehensive approach is required. How many know of or have been part of a big bang product development? It ends very well. Been part of projects in which all the technical documentation must be in place to move to the next phase of the project. We're not the sitcom. We're talking about a trick we play on ourselves when we think we can develop the entire product in one pass, or even just unplanned or vaguely planned iterations. When we do, we plan for a silver bullet and a miracle. I'm reluctant to say this never or always fails, never works or always fails, because there are limits to that, but I would say more often than not it's going to produce inconsistent and the results you're not looking for. Modern systems have become quite complicated with component on component and software iteration on software iteration. Complexity grows, so does our testing scope as we attempt to cover the entirety of the system variations solely in our testing. This works. Test cases can become quite high to assess the system. This becomes especially problematic when we develop the system from a big bang mentality, as the testing was relegated to the end of that development. Rather than put it all in one whack, we deliver iterations of the system that produce something workable in a controlled fashion. You can do this even at the component level. On a heavy vehicle. In the olden days, the instrument cluster was largely mechanical. You had was going up to the speedometer, a cable going to the tachometer, air pressure gauges that were plumbed, pneumatic. Today, the small part of the vehicle is equipped with a great deal of embedded software. In fact, the entire vehicle has numerous embedded components, embedded architecture to produce many more features and functions than were available in the past. Approach will not stand up well to this sort of complexity, and perhaps it never could. The solution we can kind of steal a little bit from the Agile guys in how they approach their product development, and that is in iterations. In fact, I would submit that old-fashioned product development mechanisms never counsel that you should develop all the product at one whack and hand it to your test guys to test at one whack. What was found in a study of 391 teams that designed custom integrated circuits. That is, this was a Harvard Business article on the 6 myths for product development by Stefan Tonke and Donald Reinertsen. We're only going to talk about one of those myths because it applies really good here, and number 6, and that is the myth of one big bang development. Teams that followed an iterative approach and conducted early and frequent tests made more errors along the way. But because they used low-cost prototyping technologies, they outperformed in terms of team and time and effort required. Teams that tried to get their design right the first time. The teams that faced high prototyping costs invested more effort on specification, development, and verification. And because they did their iterations later in the process, and they did far fewer of them, they delayed the discovery of critical problems. Experimenting with diverse ideas is crucial to innovation projects. When people experiment rapidly and frequently, many novel concepts will fail, of course. But those failures are desirable because they teach us and allow us to eliminate options quickly and focus on more promising alternatives. That is from the steps listed in that article. Just about testing, though that's what they think in that article. Ensuring that product quality is not accomplished solely through testing and verification activities. Testing is a fraction of those techniques. We have good planning will allow us, product incarnations will allow us phased and incremental delivery of the feature content. Makes it possible for us to organize and employ tests, inspections, and evaluations as tool for our competitive advantage. To really improve and prove the product quality, a more comprehensive approach that we've been talking about is required. All seen this curve similar to this, illustrating the impact of changes on a product during product development. Changing a requirement is simple. It's a document. It's a piece of paper. Changing production equipment is expensive. Changing tooling is expensive. If those changes orient from the customer due to a sudden realization about the end customer or market, or because our technical staff missed an important detail or dependency in the product. Late changes once the product is highly tooled or large investments are made, come at a price when it comes to rework. It can be fairly certain that the product development work will be accompanied by some learning. It is incumbent upon us to tailor our approach to limit our exposure to the more costly, prohibitive parts of the curve. Linked to the configuration management plan, it will describe the iterative product development baselines that build up to our final product function entirety. In other words, we describe each of our incarnations of products in each package delivery. We are essentially describing our function growth as we move from little content to our final content. Each package will have incremental feature content and bug fixes from the previous iteration. By defining this up front, we are able to specifically link the testing, inspection, and evaluation activities to not only make an iteration, but specific attributes of that iteration and capture. It is an associative data map in our CM system. In the example of testing, we know the specific test cases we will conduct by mapping the product instantiation with the specifications and ultimately to test cases. We do this through our configuration management activities. We end up with a planned roadmap of the product development that our team can follow. Of course, as things change, we will again update these documents through our configuration management actions. And ultimately, you will see we have something we call tempo to keep track of that.